Hello, this is Arlissa with 8-Minute Maths, and in this video we are going to work with exponents and polynomials. So just real quick, we have a couple of rules that one rule I think that we should, maybe two, that we should address. That is that the product rule. Product rule says when you multiply two exponents with the same base, you actually add the exponents, and this gives you x to the fifth. So x squared times x cubed is x to the fifth. Another rule, and this isn't necessarily an exponent rule, but if you are adding exponents, they must be like terms. So let's talk like terms really quick. Like terms have the same exponent, yes, same exponent, and same variable. So you can have x squared and 2x squared, but if you had x squared and y squared, those are not like terms. And you can only add and subtract like terms. You can multiply anything, it doesn't really matter, but you can only add and subtract like terms. This is a rule that seems to confuse a lot of students because they think they want to put things together that they can't really put together. So let's go back to this. X squared plus 2x squared. There's an invisible 1 as the coefficient here. So 1x squared and 2x squared is 3x squared. Notice that we kept the same exponent here. This, we just added the coefficients, but if we're multiplying x squared times x cubed, then we add the exponents and it becomes x to the fifth power. So let's do some examples. Example 1 is 4x plus 3v minus negative 3x plus v. Okay, now first we want to distribute this minus sign in the middle, so that way we get the proper signage on all the terms. That way we'll know what we're working with. So the 4x plus 3v stays as it is. This is us clearing the parentheses. So the negative times negative 3x gives us a positive 3x, and negative times v is negative v. Now let's look at what are the like terms. Well, 3x and 4x are like terms. And let me get another color here. And the 3v, come on, and negative v, which is an invisible 1 here, 3v and negative v are also like terms. 3v minus v are like terms. So when we combine these, we can only combine the things that have the same variable. Here, same variable. 4x plus 3x is 7x. 3v minus v is a positive 2v. And this is as far as we can go. We can't go any further than this because we do not have like terms anymore. X and v are not like terms. It's like x-rays and violins. They're not the same thing. Okay, so you cannot combine them any further than that. Let's go with example 2. We have negative 4p to the fourth plus 5p squared minus 3 minus 11p squared plus 4p minus 6. Example number 2. So let's first, again, we need to distribute this minus sign to the second parentheses. That is the first step. Before we start combining things, we must make sure that we've cleared the parentheses. Nothing's happening in the front here, this first parenthesis, so we can just rewrite it without the parentheses. Negative times 11p squared is negative 11p squared. Negative times 4p is negative 4p. And negative times negative 6 is a positive 6. Now let's look at what things are like terms. Well, we have a p to the fourth, but it's the only one. So we can just bring that one down, negative 4p to the fourth. Do we have any cubes? Nope, but we have a squared. 4p, 5p squared, and negative 11p squared. Did you notice how I kept the negative from in front of that 11? Well, this negative sign in front of all of these coefficients, that sign stays with that coefficient. So this is plus 5 minus 11, and we're keeping our p squared. Okay, let's look at, do we have a p? Yes, we do. So we can just, I'm going to put a straight line here, and we're going to bring it down, negative 4p. And then we have two sets of numbers. We have negative 3 and a positive 6. Putting a diamond around those two things go together. Negative 3 plus 6 goes at the end. I went in the order of the highest exponent going down. That's the proper order and proper form when you're simplifying polynomials with exponents. So we've got negative 4p to the fourth. 5 minus the 11p is negative 6p squared. All we had was minus 4p. We'll keep that. Negative 3 plus 6 is a positive 3. And we have simplified this polynomial based on the like terms. It is important to remember that you can only add and subtract terms that are like terms. You can multiply and divide anything, but you can only add and subtract like terms. Okay, so now that we've done the adding and subtracting, let's move now to some multiplying of polynomials. Example 3, we've got 5x plus 3, and we're multiplying by x squared plus x minus 2. Now, there's two ways you can do this. One, okay, we'll just start with the thing. I'd like to take the longer one and put it on the top. Minus 2. We'll call this method 1 because I will go through method 2. And we're multiplying this by 5x plus 3. And this is just like we would do if we were operating with long multiplication. We would do something very similar where we would take 3 times negative 2. 3 times negative 2, we're going to go here. This is negative 6. 3 times x is 3x. 3 times x squared is 3x squared. Now, because this 3 and the x were both positive, then this is a plus 3x there. And for the second one, make sure that we put our 0 in just like we would for long multiplication. 5x times negative 2 is negative 10x. You can do a plus 0, doesn't matter there. 5x times x. This is 5x times x. There is an invisible exponent of 1 there. So this is 5 to the x 1 plus 1, which is 5x squared. We put that here, 5x squared. It is positive, so we put a plus in front of it. And we multiply 5x times x squared. This is the same as 5 times x to the first power, x squared, which is 5x to the 1 plus 2, 5x cubed. This here, 5x cubed. Now we've done all the multiplication here. So now we can add these together like we would with long multiplication. Negative 6 plus 0, negative 6. Negative 3x minus 10x is minus 7x. 3x squared plus 5x squared is 8x squared. And this 5x cubed is out here all by itself. That would be one way of solving the problem and putting it into like a long multiplication setup. Let's go with method 2 though. I'm going to show you this one as well. And with method 2, what you're basically doing is you are distributing each term times the second parentheses. So we take the 5x and we multiply it times x squared plus x minus 2. And then we do the plus 3 and we multiply it also times the second parenthesis also. So 5x times the second parentheses, 3 times the second parentheses. And we just distribute, use a distributive property like we would have done in any other situation. We just distribute and we combine at the end. So 5x, this is 5x times x squared plus 5x times x minus, this minus sign came straight from here, minus 5x times 2 plus 3 times x squared is 3 times x squared, 3 times x, and 3 times negative 2 plus 3 times negative 2. Now we can do our multiplications. Well, there's an invisible exponent of 1 here. Using our product rule, this becomes 5x cubed. 1 plus 2 is 3. Plus, remember that there's an invisible 1 up here and here. So this is 5x squared. Negative 5x times 2 is negative 10x. Plus 3x squared. Plus 3x. Plus 3 times negative 2 is negative 6. Now, do we have any like terms? Well, the x cubed, we can just bring it down because there's only one 5x cubed. As far as the squares go, we've got 5x squared plus 3x squared gives us plus 8x squared. I'll put a circle under here so you'll know where that came from. And then we have negative 10x and positive 3x, which is negative 7x. This is where that came from under the squiggly line. And then what was left after we used everything was a minus 6. Notice that this answer and this one up here are the same answers. Okay, either way works. We can either split it out like long multiplication, do one at a time, or we can take each term in the first parentheses and distribute to the second parentheses. It really only comes down to what is your preference and which one you would like to do better or do more. It's really what that comes down to. Okay, if you have any questions along the way, I do want you to ask them in the comments so that way we can answer whatever questions you have and clarify things if they are not clear. T minus 4 times 2t squared minus t plus 6. Well, I'm going to go back to method 1 because I think I like that one the best. 2t squared minus t plus 6, and we're multiplying that times t minus 4. We're multiplying this. Okay, I'll use my marker so you'll still see what we're doing. Negative 4 times 6 is negative 24. Negative 4 times negative t is a positive 4t. Negative times a negative is positive. And negative 4 times 2t squared is negative 8t squared. Then we go with our t times 6. 6 times t is 6t. This is a positive. And t times negative t is a negative t squared. Be careful not to look at these two and say negative 2t. Okay, negative t times t equals negative t squared, not negative 2t. Do not make that mistake. It'll cause things to be wrong. And then t times 2t squared is 2t cubed. We are adding these together now, just like we would in long multiplication. We've got 2t cubed. We can start from the left. Negative 8t squared minus t squared is negative 9t squared. 4t plus 6t is 10t and minus 24. This is our solution to the multiplication of these polynomials. Okay. Now let's look at example 5. We're going to look at a cube. So we have x plus y cubed. There is a formula that goes along with two terms that are cubed. There's a formula. Now, you can remember the formula if you'd like to put your brain power on remembering the formula, or you can just multiply it outright. So the formula is the first term cubed plus 3 times the first term squared second term plus 3 times the first term times second term squared plus the second term cubed. This is the formula. If you want to put into your memory banks and memorize it, you can. But I want to work it out so we can see how we get to this formula. Let's just start with two of them. This is the same as x plus y times x plus y times x plus y. That's what this is. It is all three terms, all three binomials, being multiplied times each other. So let's just do the first two. Let's just do x plus y times x plus y. There's also a formula for this, but let's just multiply it out. So we can use the FOIL method. We can use FOIL method, first, outer, inner, last. I'm all for that. So the first would be x times x is our first. This is x squared. Our outer is x times y. Okay, this is our F. This is our O. Just so you'll know where I'm going with this. The I is the inner. This is the I. This is y times x or x times y, which is also xy. And then you have the last, which is y times y equals y squared. You take all these, put together the like terms, and you have x squared plus xy plus xy plus y squared. Well, these two in the middle are like terms. They both are xy with the same exponent. So we have x squared plus 2xy plus y squared. That's when we've taken and multiplied just two of them. Well, let's multiply the last one. So now we have x plus y, which is the last one of the cube, and we're multiplying that one times x squared plus 2xy plus y squared. What do you think about us now distributing? We can distribute this first term times x squared plus 2xy plus y squared. And then we're adding the second term, or the y, times that same x squared plus 2xy plus y squared. Let's multiply it out. X times x squared is x cubed. X times 2xy is 2x squared y. X times x is x squared. You keep the y. Plus x times y squared is xy squared. Now we're distributing the second. Y times x squared is x squared y. Notice I'm putting the x's first because that's the proper way you put the alphabetical term or variable first. So x comes before y. Then you have y times 2xy. So this is 2xy squared. And then y times y squared is plus y cubed. Looking at what like terms we have. Well, we have x squared, x cubed, we'll just keep that. I'm going to cross stuff off as I use it. Let's see what we have. Do we have a 2? We have an x squared y. We have x squared y here, x squared y here. There's an invisible 1 right here. So this is plus 3x squared y. That's including this one and this one. Well, do we have an xy squared? Yes, we have xy squared here plus 2. Remember, there's an invisible 1 right here. Xy squared plus 2xy squared is another 3xy squared. Now, this is different than the 3x squared y. Two different things. So we're crossing off those as we use them. And then what's left here is a y cubed. This is the same as the formula I told you about up here. It's the same as this, but I wanted to show you how did that formula come to be? How did that formula come into being? You can multiply it out like we just did here. In the next example, example 6, I'm going to use the formula to show you how you can solve a binomial cubed easy. Okay, so we've got 2x plus 5y cubed. This is example 6. 2x plus 5y cubed. And our formula is, we're just refreshing our minds, our formula is the first term cubed plus 3 times the first term squared times the second term plus 3 times the first term times the second term squared plus the third term cubed again. Using our formula, this 2x is our x term, and this 5y is going to be our y term for our example in the formula. So we're using our formula, we're taking the first term cubed. So we're taking 2x cubed plus 3 times the first term squared, which is 2x squared, times the y, which is 5y in our case, plus 3 times the first term, which is 2x, times y, the second term squared, 5y parentheses squared, plus the second term, which is 5y cubed. I've taken the first term cubed plus 3 times first term squared, second term, plus 3 times first term, second term squared, plus second term cubed. Now let's multiply all this out. Well, 2x cubed is the same as 2 cubed x cubed. The exponent here applies to everything in the parentheses. So it applies to the 2 and to the x. Plus, we've got 3 times 2 squared. I'm going to put this here. And x squared times the 5y. Put a dot between it just so you know we're multiplying stuff. Plus 3 times 2x times 5 squared y squared. Now this requires you to, be focused and attentive. You can't really do this kind of stuff while you're watching TV. You must, focus and attend so that way you won't get yourself confused and lose track of what you were doing. You must concentrate when you're doing these types of problems so you don't make errors. 2 to the third power is 8, and we can keep our x cubed. Plus, looking at our second term here, we've got 3. 2 squared is 4 times 5. 15 times 4 is what, 60? Yes, 3 times 4 is 12 times 5 is 60. And we have x squared y. Plus, again, if you need to employ a calculator when you're doing these problems, there is no shame in doing that. If you need a calculator, then use one, okay? There's no reason to not have the tools you need because you're ashamed. Just go ahead and use what you got to have. Next term, 3 times 2 and 5 times 5 is 25. I'm just putting that here so we'll know what we're working with. So 3 times 2 is 6 times 25 is 150. We have an x and a y squared plus 5 to the third power is 125, and we've got y cubed. We used our formula here, and we were able to expand 2x plus 5y to the third power. You could have done it the other way, like I said. You couldn't just multiply 2x plus 5y, get that polynomial with the squares, and then you can multiply what you come up with, that new polynomial, with 2x plus 5y again. Using the formula, I think, may be a little simpler. The only problem I could see having with using the formula is if you don't remember what it is. And for cubes, I don't always remember what that formula is, and I have to refresh my memory. So because of that, it's really easy just to go ahead and multiply it out. Just go ahead and do it what we would call longhand, or do it the long way. That way you can ensure that you're getting a good answer. You can ensure that you're getting a good answer. So we have covered working with exponents and polynomials. Working with exponents and polynomials. Now, in this video, I went over the product rule, also went over the rule concerning like terms. These things that I've discussed are in the Algebra Survival Kit. These things we just talked about are in the Algebra Survival Kit, and much more in depth. They're much more in depth, by the way, but they are in the Survival Kit. Okay, you can get some practice on working with exponents, working with polynomials. How do we add, subtract? How do we multiply, divide? All of those things are in the Algebra Survival Kit. Good practice on these same topics. Of course, there's a lot more than 6 examples. I work them all out and show you the solutions as well. The address here is bit.ly/algebra-survival-kit. It is only $50 for this month because it's my birthday month. And at the end of this month, it will go back to its regular price of $88. So go over to bit.ly and avail yourself to that. Let's look at what are the things that are in the survival kit. Well, we've got the get off to a good start, success strategy, algebra cheat sheet, formulas, basic refresher videos. These are videos that are the things your teacher is going to expect you already to know. Exponents, solving basic equations, inequalities, how to work with rational numbers and fractions and decimals. All that is in here. It's in video form, so you can get a nice little brush up on it. Easy ways to remember formulas. Okay, reviewing the prerequisites is here. Things that you would know ahead of time. Exponents, rational numbers resource. 3 ways to make it successfully through the semester. Then you get to the meat of the content: polynomials, factoring, functions, systems. And then at the end, you want to finish, definitely want to finish strong. As you've spent time with me, I want you to know that we are available for you on several different platforms. Along with being available here on Facebook at 8-Minute Math Help, we're also available on YouTube. Alyssa Pinkleton, we've got a channel there where we do a lot of these videos are uploaded there. We also have 8minutemath.com, where there's a blog and freebies and all that good stuff. Basically, we're here to support those who are returning to college, and this is me down here. All right. So I look forward to seeing you in the next video. We will go more in depth into polynomials, working with dividing polynomials and getting more in complex exponents and polynomials. All right. I hope to see you there, and check me in the next video. Thanks. Bye. If this video has been helpful to you, then subscribe to the channel so you can be notified when new videos are posted. Also, visit us at 8minutemath.com, where you can see our content and resources and courses, things that are available to you there. Lastly, follow us on Facebook at 8minutemathhelp.com. We look forward to seeing you there.